Welcome to the calculation section of our course. This is where we build on what basic calculations are needed to complete an LED installation. Now, people know about power, and yes, we have to work out power and how much power is being consumed, but there are little details we need to know when we're specifying power supplies, not just the power. We have to leave some room on those transformers. So we're going to look at power calculations, then we're going to look at voltage drop calculations, and then I'm going to touch briefly on lighting output calculations. These are the major calculations you're going to need and you need to understand when you're going to perform a fantastic installation. And this is what this course is about. We're building on small details, treating you as if you have no knowledge on the topic, and we're slowly building you up. So congratulations for making it this far, and we're looking forward to continuing the course with you until we reach the finale, where we teach you the actual installations and how to make that lighting look fantastic. So let's dig into it. Power calculations we're going to look at. So people may be familiar with Ohm's law, which is voltage is equal to the current multiplied by the resistance. But for LEDs, we're going to look at this formula, which is power is equal to IV. And power is essentially, think of the work being done to power up something, and that is measured in watts. The current is measured, which is I, with the symbol for current is I, is measured in amperage. Just going to put amps here, and this symbol is W, this symbol is A, all multiplied by voltage, and that symbol is V. So power is equal to, the work done is equal to the amperage multiplied by the voltage. So I'm not going to go and explain it very deeply, but this is the formula that you need to know how much your LEDs are going to consume. This becomes very relevant when we dig into wire calculations, but right now we're focusing simply on power calculations. How much power, or how much work is being done in those LEDs, how much power it's consuming. That formula is P for power is equal to the amperage multiplied by the voltage of that LED. So let's look at this quick example. The key thing, you always have to know the power ratings of your LED. And what you're going to see here, that this LED has power ratings on it that is 7 watts per meter. And let's write that down. So this rated power of this LED, 7 watts per meter. So this LED is 7 watts per meter, or 2.13 watts per foot. The other data input we're going to need is the voltage input, and you can see this is rated at 12 volts DC. So input voltage is equal to 12 volts DC. Now, if I want to know the total power consumption of that LED, so let's say it's a 5-meter run or a 16.4 meter run, what I'm simply going to do is I want to know what the total power consumption is, and that is equal to the rated power per meter or per foot times the length. Always remember to use meters with meters and feet with feet. So if we're doing a calculation of, we said for 5 meters, so 5 meters is our total length. So the rated power is 7 watts per meter multiplied by 5 meters, or 2.13 watts per foot multiplied by 16.4 feet. And let's see what calculations we get on those. So we know here is going to be 35 watts, and with all the decimal points it's going to be 35 watts. So to understand the total consumption on your linear and LED strip, it's going to be the length and multiply by the power rating per length. Now, it's your very basic calculation to know how to understand the total power consumption of an LED system. What if we wanted to find out the amperage of the system? I'm going to show you how to manipulate the formula. So if you wanted to understand the amperage or the current, it's going to be I is equal to the total power divided by the voltage. So let's say I had that 35 watt LED and I divided by 12 volts, roughly 2.9 amps. In our systems, we tend to use a lot more 24 volts, and that's because there's going to be less voltage drop. So 12 volts LEDs are very good for localized power supplies and cabinetry. But if you're doing linear lights in the ceilings or multiple systems that are far away from the power supply, you want to opt to 24 volts or even 48 volts. So let's look at the calculation and let's see how the amperage drops. You have 35 watts divided by 24 volts, and you're going to get roughly 14.6 6 amps. So as the voltage goes up, the amperage decreases. So that's the basic formula that you need to understand for calculating the total power of an LED linear system. If you're using bulbs or any other LED product, the wattage would be listed on the device itself. Products that are linear strips or prefabricated linear strips, it should be rated, but if you're dealing with raw material, you need to understand what the power rating is per foot or per meter, and then you simply apply it into the formula. P is equal to VI, so power is equal to voltage by the amperage, and that's it. You're going to get the total power consumption needed for your LED linear install. So let's look at the other calculations.